So here's some more converting between polar to rectangular. So again, sine is equal to y over r, and cosine is equal to x over r. So I get r is equal to 1 over 2 times y over r minus x over r. The smartest thing to do here is to cross multiply, because then all these r's are going to cancel out. So this is r times 2y over r minus x over r is equal to 1. And if I distribute that r, I get 2y minus x is equal to 1. You don't really need to solve for y, you're just noticing that this is a polar form of a line, this is the rectangular form of a line, and these two are equivalent. Again, the trick is, I notice I reduced the number of r's quite quickly by just cross multiplying. There's other ways I could have done this by multiplying this one, the top and bottom, by r, and have these r's cancel out, but then it just becomes, could become uglier. So that was just the quickest way to handle that problem. So here we have r cosine squared times 2 sine theta. So again, cosine is equal to x over r. So this is r x over r quantity squared equals 2 times sine, which is y over r. Y over r. So if I square this, I get x squared over r squared is equal to 2y over r. And notice that one of these r's cancels, so I get x squared over r is equal to 2y over r. And if I multiply both sides by r, all the r's cancel out, so I'm left with x squared equals 2y. And let's just write it as y equals 1/2 x squared, dividing both sides by 2. And so notice that this is a parabola in polar form, and this is a parabola in rectangular form. So here's a little bit different one. Here we have secant theta, and we have tangent theta. So tangent is equal to y over x. And secant is just going to be the reciprocal of x over r. So if cosine is x over r, that means secant is r over x. So r is equal to y over x times r over x. Oops. R over x. So I get r equals yr over x squared. I'm going to cross multiply, so I get x squared r is equal to yr. And notice if I divide by r, I get x squared equals y. And again, I have another form of a parabola. Pretty ugly looking polar function. Pretty straightforward Cartesian. Okay, so we have r squared is equal to x squared plus y squared, and secant is just going to be the reciprocal of x over r, so r over x. So we have r squared is equal to negative 3 times r over x. I'm going to cross multiply, so I get x r squared is equal to negative 3 r. I'm going to get rid of one of my r's. So I get x r is equal to negative 3. Then I'm going to solve for r. Here's a little trick here. And now I'm going to square both sides. So I get r squared is equal to 9 over x squared. R squared is equal to x squared plus y squared is equal to 9 over x squared. And then I'm just going to multiply both sides by x squared, so you get x to the 4th plus x squared y squared is equal to 9. And it's a pretty unattractive answer, but it's not that bad. There's a couple different ways we could have done this. We also could have just let r equal the square root of x squared plus y squared. So we have x r equals negative 3. So x to the square root of x squared plus y squared is equal to negative 3. And I could have squared both sides and got x squared plus y squared is equal to 9, and then distribute that x squared, so you get x to the 4th plus x squared y squared is equal to 9. So both of those are the same result. You didn't really necessarily see the trick of squaring both sides. You could have just replaced the r with the square root and then square both sides, and nice things happen. So our final example here has tangent and sine. So tangent's y over x. So I have r over 3y over x equals sine, which is y over r. So I'm going to cross multiply. This y is going to be multiplied by this whole denominator, and those two r's are going to be multiplied. So I get r squared is equal to 3y squared over x. R squared is equal to x squared plus y squared equals 3y squared over x. And I'm going to multiply both sides by x, so I get x cubed plus xy squared equals 3y squared. And that's the best you can leave that answer. It's pretty unattractive, but I'm okay with that. All right, that wraps that up.